Okay, so the angle measures again. I'm sorry about that. This is 55 degrees, 55 degrees, and then in the corner here is 51 degrees, all right? So why don't you and a partner just discuss briefly what you think is going to be the bigger angle, okay? Or the bigger side, WX or YZ? Or WX or XY, I'm sorry. Oh, and let me help out really quick too. So we found that WZ is the same length as YZ, right? Is there any other side on these two triangles that is similar in length? Yeah, Sophia? XZ. Because what about X? Or what about XZ though? On these two triangles? How are they the same? Not necessarily a bisection. It didn't cut anything in half, yeah?
Midpoint?
It's not the midpoint. It's literally the same side. So we call that sort of like looking into a mirror. It's the reflexive property. So the fact that they share this side means that they have the same equal length, right? So it's like you and I, if you and I shared an arm together, it's like saying that we have the same arm length, because guess what? It's literally the same arm. It's just you and I are both sharing it, okay? So it's the same thing here. XZ is the same length because they're literally sharing the same side, okay? But that leaves us with one more thing. Who is going to be bigger, WX or XY? Yes, Sophia?
XY.
XY will be bigger. And again, how did you know that?
Because of the Hinge theorem.
The Hinge theorem. And the Hinge theorem says that if your two angles here, if you have two congruent triangles with two congruent sides, but that third side is opposite of a bigger angle, you will have the bigger side. Okay? So again, that's what Hinge theorem is saying here. This is the opposite of Hinge theorem down here. This is called the converse of Hinge theorem, right? It's saying almost the same thing. However, look at here. PQ and JK. Like if you look closely, these two triangles have two similar sides as well. There's a congruent side congruent to here. KL and QR are the same, and JL and PR are the same. But who's bigger, PQ or JK? Well, PQ is. PQ has the bigger side. So that means the angle opposite of that, the angle opposite away from the side over here and here, L and R, who's going to have the bigger angle, L or R?
L. No, R.
Yeah, it's actually going to be R. So it's the opposite. If you have the bigger third side, the angle opposite away from it's going to have a bigger angle. Okay? So this is the converse. This is the opposite. Here it says that if you have the bigger angle, then you have the bigger side. Over here it says if you have the bigger side, then the angle opposite of that is going to be bigger. Okay? So it's almost the same sort of logic. I'm going to give you one more problem. It's going to you're going to have one line here that's going to be FC. And then you're going to make a triangle right here that's going to have one congruent side to this side over here. Only you're going to kind of make this side kind of lopsided. It's going to kind of like point outwards a little bit more. This one from F to B. And then you're going to make that point connect to BC. This is 3.6 and this is 3. Okay. And I want you to find the relationship between the measure of angle FCD and the measure of angle BFC. Who is going to be bigger or smaller? Okay. So there's two different triangles here. You want to be able to identify them. Okay. And let's see. Is there any other side that's going to be congruent to each other? FC. So we're looking at the third side and we're looking at FC to, what is it? BFC, I'm sorry, BFC. So we're going to look at this angle here and we're going to look at FCD up at the corner in here. Who's going to be bigger and who's going to be smaller? Okay. So solve that for the next few minutes and try to decide which one's going to be smaller or which one's going to be bigger. All right. Has anybody come up with an answer for which they think is going to be? Sophia, go ahead.
Angle F.
The FCD?
No, okay. BFC.
BFC is going to be bigger. That is correct. And how did you know that?
Because of the what's it
Sorry, you don't have it written down on you.
called? Hinge theorem.
It is the Hinge theorem. And specifically, out of both of these Hinge theorems, it's the converse. Because you knew that the third side was bigger than the other third side over here, right? The third side of this triangle is 3.6, and the third side of this triangle is 3. So henceforth, the angle opposite to those guys, BFC is going to be bigger than FCD, okay? So that is the converse of the Hinge theorem. So now we're going to use this idea with a little bit more complex math.
No.
Don't worry. I think it'll be okay. You're going to be okay, Sophia, right? So the next one is going to be applying. So this new section, or it's going to be 7-6 still, but we're going to applying algebra to the relationships in triangles, right? Applying algebra to the relationships in triangles. Using what you know about the Hinge theorem, here is an example problem that we're supposed to solve. It's going to ask you something odd. It's going to ask you to find the range, oh, thank you. Find the range of possible values for x. What do you mean by that? I'm going to give you this, okay? I'm going to give you, let's see, how am I supposed to, I'm going to draw this. I'm going to draw a triangle that comes up to this point here. I'm going to name this J. This is going to be E and H. And then I'm going to draw point G that's a little bit higher than point J. I'm going to connect them now to this guy. And I'm going to say JH is congruent to G. This is a point G. So HG is going to be congruent to JH. JE is going to be 8, and then EG is going to be 9 units long. And in the corners here, this corner over here, and this corner, right? 6x plus 15 degrees. That's how many degrees it is, okay? That's an angle measure right here. This angle measure doesn't have a real number yet. It just has 6x plus 15. And this angle over here, this angle measure is going to be 65 degrees. Normally, we would set that equal to each other, but these two triangles are not the same. They have two sides that are congruent, JH and GH. Do they have any other side that is congruent on both triangles? Yeah, EH. That is correct. Look at their third side, though. JE and EG. Who's got the bigger side? Yeah, JE. So who's going to be bigger? This angle, 6x plus 15, or this angle, 65? Yeah, 6x plus 15 degrees is going to be greater than 65. All right.
Wait, is that what is that after the 9?
Well,
Corner?
in the right here?
Yeah.
That is a weird G.
Oh.
Admittedly, that is a odd looking G, okay? Let me ask you right now. Can you think of a number that you can plug in for x? It doesn't have to be the perfect one. Just think of a number in x that you can make this statement true. That this left-hand side has to be greater than 65. 10. Let's just say that. What if x was equal to 10? Would this number be greater than 65? Let's do that. Let's do this in our head. 6 times 10 is 60 plus 15. 75. Is that greater than 65? Yeah. Think about another number. What else could be bigger than...
11.
11? 6 times 11 is 66 plus 15 is 81? Yeah. Lena's confirming. Yeah, definitely 81. Is greater than 65? Yeah. So that is another value for it. The thing is, because this doesn't say equal, this means that x could be a whole bunch of different numbers, right? But we want to narrow down what that range is. So that's what I'm asking. Find the range of possible values for x. That means x could be a whole bunch of different numbers, okay? How do we do that, Mr. Wee? Well, it's actually not as bad as you think. Just solve for x right now as if this was an equal sign. So here's what you would do. You subtract 15 from both sides. Then you get 6x is greater than 50. Then you divide both sides by 6. And then let's see if you can use a calculator for this if you would like. Please tell me what 50 divided by 6 would be equal to. 8.3. And I think there's a whole bunch of 3's, right? So we'll put that repeating sign. Let's see if that's true. All right. What's a number that's less than 8.3? Any number that's less than 8.3. 8.2. Let's think of something even easier, a whole number. Just 8 even. If I plugged in 8 back into the original statement, 6x plus 15, remember this angle being bigger than this angle, 6 times 8 would be 48 plus 15. If you plug that into your calculator, I believe that is 63, right? Is this side now bigger than 65? No. So this tells you that your x has to be bigger than 8.3. But I'm not finished yet. Okay? I know the range means that whenever you hear range, you got to have this sort of thing. You got to have a range where x is going to be bigger than a number, but also smaller than a number. So far, we got 8.3 repeating. Okay? The question is, what are we talking about on the left-hand side? Does anybody remember what all triangles have to equal in terms of their angles on the inside? They have to add up to how many degrees? Yep, that's correct. I just want to see because Shamari was like, I thought she was mouthing 180. Yeah, you were? Okay. Very good. So does that mean that this angle alone can be 180 degrees? Or else, if that happened, where would the other two angles look like if they're supposed to all add up to 180? It'd be flat. Would we even have a triangle anymore? We'd have a straight line. Get it? Because the lines are 180 degrees. That makes sense, right? So that means that this angle has to be, by default, smaller than 180. Sorry, 180 must be greater than 6x plus 15. That's how we solve for this number here. X has to be bigger than 8.3, but once we solve for this guy down here, minus 15, minus 15, this is what your book says, so that way your book doesn't confuse you, right? 180 minus 15, I believe, is 165. And 165 is equal to 6x, thank you. Or greater than 6x. We have to divide both sides by 6 now. Now someone can plug in their calculator, 165 divided by 6.
27.5.
Yes, 27.5 is greater than x. So this tells you this is your final answer. X has to be between 8.3 and 27.5. Okay? That's how you solve for these ranges. Remember, when I ask for range, I'm going to ask you for two numbers. One number that X is going to be greater than, and a number that's going to be less than. Or I'm sorry, yeah. So 27.5 is greater than X, 8.3 is smaller than X. Those are the only numbers that will work. Numbers that will, it has to be between these two numbers, or else this angle is not real. Okay? All right, so let's try a problem now, and let's see. Let's give a look here. Okay, let's try. Do I want to do that one? You know what? I'm going to give you a little bit of a tricky one. I'm not going to give you the angle this time.
No.
I'm going to give you this. And you guys are going to have to work on, let's see. You guys are going to have to work on the whiteboard. I'm going to come around and help you guys, all right? So this is 50, and this side is 50, so making these sides congruent. Then these sides down, up and down here are congruent. This is going to be 47, okay? And this is going to be 5x plus 2. Let me give you a hint. In this corner, okay, it's going to be 68 degrees. In this corner, it's going to be only 55 degrees. So before we begin, which side is going to be smaller? We're going to only compare the sides with the x because I want you to find the range for x. Find the range for x. Which side is going to be smaller? 5x plus 2 or 47?
5x plus 2.
How did you know that?
Because the angles.
Yeah, this is a smaller angle than 68. And you know that these two sides are congruent and these two sides are congruent. The only thing different is the angles. So that means the third sides are not going to be the same, right? So we have 5x plus 2 is smaller than 47. I know you can already solve for one part of the range, okay? It's just the other part you're going to have to do. So everyone please stand up now, okay? Find a space on the whiteboard in the back. In Shamara, you can pull up a whiteboard, like one of those whiteboards, and keep it to your desk, and you can work on it with someone, okay? I want everyone, all of you guys to stand up and then work with each other, okay? On how to solve for this, right? I want you to try to solve for this. I'm going to help you out. Oh yeah, and I have more markers up here in this bucket. Thank you, sir. Okay. Hi.
Other way.
This way?
Yeah.
There you go. Okay. Yeah.
We'll grade my test.
No. I'm in the middle of teaching class, so no, you can't grade your test.
Wait for this. I have a question. Wait.
Okay, it's got to be a quick question, okay?
Yeah, just
Because they come first. They're in my class.
I'm in your class.
Yeah, but from like 2 hours ago. So right now, they're my priority, not you.
Oh yeah, number 5. You just need to You don't need. You just have to find X, Y, or Z. You don't need to find all.
You don't have to find all three. Just choose one.
Okay.
Yes.
From 10, do you want us to figure out what each of the values are?
No, just X. Just X. Yes. Okay, so what do you guys have? Very good. All right. And how did you guys get 36?
From
So let's see. So that would be true if we were talking about angles, right? But is this an angle? 5x plus 2? Is that an angle or is that a side? So we can't say that it's going to be less than 180. But think about it this way, right? 47. Oh, we know that it can't be bigger than 47, right? And then what did you guys get? You guys got x's. Okay, this is. I want to see what theirs is too. I just want to compare. Okay, we're on the same track. Good. Okay, x can't be greater than 9, but x can still be greater than a number. What can the side length never be? Can't be 47, but let's think of the opposite. What's the smallest number that it can never be? Or else it doesn't make a lot of sense. Where's the length of the side? Like if I said, look at this, or actually, what is the length of my finger? What is the shortest that it can ever be? What if it was 0? Would that make any sense? Why would that not make sense? There, right? Same with this here, 5x plus 2, or was it? It's 5x plus 2, right? 5x plus 2 has to be greater than what number for it to exist. You just said that the finger wouldn't exist if it was the length of 0. So could I ever have the length of 0 for this 9? 5x plus 2. So you're just going to say that. Okay. So it sounds ridiculous, but that's how you find a number. Because that doesn't make sense, right? You have to find a number between 9 that is less than 9 but greater than 35.6. So you see what I mean? That range doesn't quite make as much sense.
Yeah.
But if we subtract 2, we get 5x greater than negative 2, and we divide both sides by 5, we get x greater than negative 2 by 5. That makes a little bit more sense, doesn't it? That's going to be your confidence. Maybe write this down too. For your notes. Thank you. Okay. Oh, thank you so much. Thank you, Colin. Gentle person. I appreciate that. Yes.
This is 27, right?
Yeah, that is.
Okay, here you go.
Put right on. Thank you. All right, very good job, guys. You guys are doing wonderful.
Thank you.
All right, no problemo. Okay, so let's see. Do I want to go through this one? Let me see if I have a proof on this. You guys love proofs, right? No, not at all, Mr. Wee. I really don't like proofs. Okay. Well, I'm going to have to go through one more proof with you, okay? Before I move on. And then and I believe most of the other sections from this point on don't really have a proof. So let's see if we're going to go through that. Angle addition posture, definition of Hinge theorem here. You know what? Okay, so here's the deal. 7-6, this is the very, very, very last tidbit of proofs for a while, I believe. Let me see if when's the next time we're going to look at proofs? So whenever you see triangles, you have to understand that you're going to have to do proofs. But not for a while. I believe we're pretty much out of the woods for most of the proofs at this point. So here's the deal. Since we've already done an extensive amount of proofs now, okay, I think this is the hardest chapter for the proofs, right? I don't necessarily think that you're going to have to know the proofs for this section, okay? I think proving triangles congruent to each other, remember SSS, SAS, I think that's where we max out at proofs, right? So just letting you know, if you haven't, write this down. this is going to be a modification to your cover sheet. Any problems with proofs in this section, please do not do them. Even if they're assigned to you, please do not do them, okay? I do enjoy seeing a big smile on Sienna like that. That was probably the fastest, biggest smile I've ever seen from you, Sienna. Right? So hopefully that's an indication that you can kind of see some mutual benefit from this. Because I don't think it'd be beneficial for you to know this. In fact, I think Hinge Theorem is enough. Finding the range, that's not easy. Right? Especially not easy to remember. So I encourage you to learn the Hinge Theorem more than you are trying to learn the actual proofs, right? So without further ado, let's move on to 8-1. That's going to be great. I know you guys are excited about this. I can smell it. I can feel it. I can feel the hunger and the urge to learn. Did you know that, not to emphasize this, but sometimes it's good to be mindful. Can you guess what time is the hardest time for students to get over in the school year? To get over in the school year. Because, the whole school year is pretty tough, right? But statistically speaking, you know which one's the hardest to get over? You want to take a guess? No, you don't? No? Try now. March is, statistically speaking, the hardest time of the school to get over. February and March, but I would say March. Why do you think that is? It's in the middle of the school year. And what's the difference between right now and last year in the fall?
They were teaching the 3 part because it's usually 3, 4. They were teaching the 3, now they're teaching the 4.
Like the months or something, or what?
No, now it's usually 3, 4, like Spanish 3, 4.
Oh, for you're talking about the difficulty of the curriculum.
Yes.
Yeah. Oh, okay. Yeah, you can think about it like that. Yeah, the material gets a little bit tougher too in general. That's right. Are there any holidays around this time too? Maybe spring break, right? But that's not for how long? Huh? Yeah, that's like a whole month away. So in terms of breaks right now, I think this and not May. May moves fast, okay? But the time right before spring break is what we call the lull. Even for teachers, you'll notice teachers are a lot more slumpy. Hello, class. Welcome to class. I don't think anyone's like that here, but just letting you know this is the toughest one. So if you feel a little bit like, when is this going to end? Okay, it's very normal for teachers and students to get through this. It's really tough, okay? Starting a whole new semester, no real holidays in sight. It's pretty tough, okay? So get through it, right? Once you get past this, it's going to be fast, okay? It's going to be a race to the end. Okay, yes, do you have a question?
I think with my backpack.
Okay, right. That wasn't your backpack, though, was it? That was a ball, good sir. Yes.
Oh, never mind. I didn't bring a backpack today.
So you did that to take the ball.
He was so obvious.
Yes, he's quite a character. Yeah, I don't know what to make. Okay. Well, let's thank him because he got us to laugh a little bit. Right, there we are. Yeah. So much positivity to be found. Okay. Sorry. Not areas of polygons. Angles of polygons. Doesn't that excite you? Okay. I want everyone to find a whiteboard space now. You and a partner, right? You want to be alone. That's fine. Okay. Draw a triangle. Just doesn't have to be perfect at all. Just draw a quick triangle and then tell me. I like that Sophia did that. Sophia, you drew one that is not too big, okay? Because you can draw as many shapes as you can, right? Draw a triangle. How many degrees is in that triangle? Total. Like angles, huh? 180, okay. Now, can you draw me a 4-sided shape, otherwise known as a quadrilateral? So here's what I'm going to do. I'm going to say this is 180 degrees, and now I'm going to draw any 4-sided shape. I don't care what it is. It could be a lot uglier than that. It could be a lot nicer than that. Now try to fit in, only using the corners, the vertices, okay? Draw me as many triangles as you can that don't bisect each other. And tell me how many you have found.
Inside of these.
So here, actually, dang it, you're actually right, Sophia. Only using the corners though. They have to connect to the corners. I'm gonna tell you this. I'm gonna give it to you right there. How many triangles do you see?
2.
Okay.
So,
Draw me a 5-sided shape. Is that 5-sided? 1, 2, 3, 4, 5. Okay, same rules. Okay, how many triangles can you fit in now? Yeah, you got good. And how many did you get?
3.
All right, so let me see how many I can get. I got 1. Let's see, am I missing one? 2. Yeah, I got about 3 as well, right? 3 triangles. Yeah?
What if you do another line across it again?
Where? Here?
Yeah.
Here to here?
No. Here, dang it. Like an X.
Oh, like here?
Yeah.
Then they'd be bisecting each other. I don't want any
Oh,
bisections. Yeah. So there's 3 triangles. So that's so does anybody know the name of a 5-sided shape?
No, but Google knows.
Google knows. Okay, go ahead. Ask Google.
What do you call a 5-sided shape? Google does not know. Oh, okay, doesn't know.
Does that seem familiar? I just wrote it.
Yeah.
The pentagon. How about a 6-sided shape, guys? Why not?
Hexagon.
Yes, it is. 1, 2, 3, 4, 5, 6. How many triangles can you draw now?
Four.
Yeah. All right. So let's see. Yeah. So that's how I drew my triangles. You might have done them different, but I got 1, 2, 3, 4. So that is a hexagon. Okay, so let's list now how many triangles there are. So n is the number of triangles. I got 1 here. How many triangles in quadrilateral here? I'm sorry. No. Let's not do that. N represents the number of sides. I'm sorry. So how many sides to a triangle?
3.
Okay. How many sides to a quadrilateral?
4.
How many sides to a pentagon?
5.
And how many sides to a hexagon?
6.
Okay. How about how many triangles I found for a triangle? How many triangles are there?
1.
Okay, there's only 1 triangle. Okay. Okay, how many triangles? So I just drew a triangle, right? Like a little triangle symbol. How many triangles in a quadrilateral?
2.
How many triangles in a pentagon?
3.
Hexagon?
4.
You might have heard of septagon. You don't have to draw a 7-sided shape. We don't even have to draw it. But what do you think? That's 7 sides, right? How many triangles do you think will be in there?
5.
Yeah. In fact, do we have a weird pattern going on? What can you tell me about the relationship between the number of sides in the triangles? What does it look like is happening right now? Yeah, Shamaria. I haven't heard from Shamaria.
Well, the number of sides, it kind of goes in order. So it's like 3, 4, 5, 6.
7.
And 7.
Mhm.
And then it does the same thing with the number of sides.
Cool. And then let's think about n is equal to 7. This number size is 7 and 5 triangles. What's like how many more sides are there than there are triangles? Yeah, Alina?
2.
How about over here, Alina?
2.
How about over here?
2.
How about over here? Isn't that a weird thing, right? Every shape that you can think of, the number of sides, if you subtract 2 away, that'll tell you how many triangles you can fit in, okay? And let me do you even one better, all right? We knew that this is 180 degrees, right? For a triangle. Total inside. What you don't know are the rest of the numbers. A quadrilateral has 360 degrees inside. There's something going on that's kind of fishy here. Yeah, what do you got?
So to figure out how many, the degrees total for the pentagon, you multiply 180 by 3 because there's 3 triangles total.
Or how many triangles in a quadrilateral?
2.
2. So if you multiplied 2 to 180, you get 360, right? Because there are 2 triangles in there. I'll say this without even doing any math here, that the pentagon is 540 degrees. Why do you think it's 540 degrees, Sophia, using the same logic you just told me? In a pentagon, how many triangles are there, Sophia?
3.
And then each of those triangles can hold up to how many degrees? So if I multiply 3 times 180, what do you think I will get? 540 degrees. So this should tell you right here, if you want to find the internal angle measure, you just take the number of triangles you have and multiply it to 180. A hexagon is proven to have 720 degrees. That's 720. I apologize. And a septagon has, let me see, that would be 900 degrees inside. So, yeah, Georgia? What is it? Does it say or, I think? No? Yes, you do. X, Y, and Z. Yes, for that one you do. Yes, you do. I thought you were asking to volunteer for this. I'm like, wow, you're really backing in this? Okay. So there's obviously a relationship between the sides, the triangles, and the angles, right? So they made a table in here in your book saying almost the same thing as what you and I were talking about. Only they added this weird thing called the n-gon. What this says is I can figure out the angles for any side. You can say 700 sided, okay? Trivia question. If I had the more sides I add, what is my shape eventually going to look like? Just this is a question that's a little bit off topic, right? I have 3 sides, right? Then I have 4 sides, right? Then I have 5 sides, right? Then I have 6 sides. 2, 3, 4, 5, 6, 7. Okay, 7 sides. I have an 8 side. That's an octagon, right? What is this kind of looking more and more? I think I drew a hexagon by mistake. Okay, sorry about that. Let me draw an octagon. 8 sides. Okay, what if I kept going on and on? What does it look like it's becoming more and more? What if I had like a million sides? Yes, eventually you can look at a circle. In some ways, for some reason, some people think it's the ultimate shape because it's as if it had an infinite amount of sides and eventually just made it look like as if it's circular. Okay? So just a little bit of trivia right there. We all coalesce at circles. Life is circular, right? That's a metaphor. I can't say that. No. Okay. So here's the deal. This is what's called the poly-interior angle sum theorem. This looks really intense. You're like, whoa, I don't know what any of this means, okay? But it says this. I can find out how many degrees is in any shape I wanted to. All I have to do is so we're going to write the poly-interior sum angle. And let me know if this makes sense to you after what we just talked about. And what this says is if n was my number of sides, the number of sides and I wanted to find the sum of any sided shape, the angle sum, if I wanted to find the angle sum of any sided shape, I would take the number of sides, which is n, subtract 2 from it, and then multiply it to 180 degrees. So let's take an example. Again, pick whichever one you want. Triangle, quadrilateral, pentagon, hexagon, or septagon. Out of these guys. A septagon. So if I wanted to find out how many degrees was in a septagon, what would I plug in for n? For a septagon, I'd say 7 minus 2 times 180. And then what is 7 minus 2? 5. And then 5 times 180 would be 900. There you are. And then just like we set up here, because that's why a septagon has 5 triangles inside. So that's why I'm multiplying 180 by 5. That's basically what you're doing anytime. Okay? So that is what we call the poly interior sum angle. You can find out the angle measure of any sided guy inside, right? Okay, so let's now do an example with our newfound knowledge. So this is a subtopic. It's called find the interior, sorry, that says interior angles sum of a polygon. Oops. It's going to be really loud. So for now, I'm going to post up these videos, okay, that we do in class. I'm going to post them up online. So anything that you missed in class, you can go back and rewind and see maybe a part that kind of confused you, okay? This is the future of classroom technology. Simply just recording and then just going back and seeing what the teacher said, okay?
On your YouTube or Google Classroom?
It's going to be on YouTube.
Okay.
I don't know, but it'll be on my website. So just go on the website and like right next to the cover sheet, there'll just be links like videos that we recorded or something. Okay. It'll say the section number, like 7-9, 8.1, whatever it is. Okay. So here's an example of something where you're gonna have to find the interior angle sum of a polygon. So let's see. We're going to find a septagon. By the way, I'm sorry. That was a heptagon. I apologize. Well, actually, let's do something a little bit tougher. Uh-oh. Wait a minute. Find the measure of each interior angle of quadrilateral ABCD. If you hear quadrilateral, how many sides are you thinking that they're going to be? Yeah, there's going to be 4. Here's what it's going to look like. A, B, C, and D. It's going to be x degrees, and this is going to be 3x. We need to find, can you tell me what the angle, so I want to find the angle of A, angle of B, the angle of C, and the angle of D ultimately are. That's my goals, right? Those are my goals, okay? What are B and C equal to? Does anybody know what B and C are at least equal to? Yeah, Lena? They're both equal to 9 degrees. So B and C, not B and D. Mr. Lee's crazy. How do we find A and D? That's the shucks moment. I don't know what to do. Yeah, what do you think?
So you do the n minus 2 equals 180.
Yes, okay. N minus 2 times 180. Uh-huh.
You plug it in for the quadrilateral.
Uh-huh.
So that'd be 4 minus 2
Times-
equals 180.
Uh-huh.
And then do the math for that.
So that'd be 2 times 180, which is it's 300,
Yeah.
360. Okay.
And then you divide it in half.
Oh, you divide it in half?
The 360.
The 360? Okay, all right, we can do that. 360 divided by 2. Uh-huh.
And then that'll equal for A and D. Like first half is A. So, oh wait, never mind. I was stupid.
Well, coincidentally, though, Sophia, that would work for this problem, but that's not how we want to do this normally. No. And stop saying that's stupid. I'm really tired of you saying that, right? It's like saying that about your boxing, okay? You just, especially when you're first beginning, you don't do that, right? That doesn't encourage anybody. That doesn't help anybody. You're merely just growing and improving, okay? So it's not stupid, okay? So think about it this way. B, C, A, and D all add up to equal what? If we know that if they're all inside this quadrilateral, in the quadrilateral, the total angle measure is supposed to be what on the inside? 360. So if I added angle B, angle C, and angle D, they will add up to 360 degrees, right? And then I know already, because you guys have told me that B is 90 and C is 90. What about A? Do we have anything for A? Even though it's not even a real number yet. Do we have anything for A and D right now? What? It's not 90 because this is 90 because there's a right angle assigned there. B and C are 90 degrees, right? Well, hold on, Luke. What does it say it is? Huh? No, just right there. What's the letter right there? 1x.
Yeah.
So D is, we can replace D with an x. And how about A? Yeah, we'll just plug in the 3x. And then we'll just solve for x for now. Why not? So 3x plus x will be equal to 4x's now, plus 180, because 90 plus 90 is 180. And you have 4x plus 180 is equal to 360. What you're going to do is you're going to subtract 180 from both sides. And then you get 4x is equal to 180. Now solve for x. Divide both sides by 4. So that way the 4 and the 4 in front of x can cancel out. Now you can use your calculator, yeah?
If 360 minus 180 is what? Is 360 minus 180 180?
Yes, it is.
Oh.
Think about it, just to kind of go back.
Oh, never mind.
No, Shamaria. Let's make some relationships here. How many degrees can a triangle hold in? 180, right? And then there's how many triangles can I draw in a four-sided figure? 2, right?
Yeah.
So there's 2 triangles in there. So if there's 2 triangles, I could take 180 and multiply it to 2, and then I get 360. So if I divide 360 by 2, you should get 180. So the logic kind of works back and forth, right? So it's not bad. And then x should be, as you were saying, 45 degrees. It's not quite finished yet. It just tells us what x is. X is going to help us to find out what D and A are. So if D is equal to 1x, then how many degrees is D now that we know what x is? Uh-huh. But what are we going to do with A? It's not exactly straightforward. A is 3x. So how do we find the measure of angle A? Yeah.
Could you use what you just? Could you use 45
Uh-huh.
and then multiply
By 3. 3 times 45 degrees. Or if you had to know, we'll write on the side that was 3 times x. That's why we were doing it in the first place. Okay? That's why. And then that should be 135 degrees. Okay? So if you want to check that, you can add 135 plus 90 plus 90 and 45. If you did it right, that should add up to 360 degrees. Okay? That is a lot for this shape here, right? You guys want to try one now? Yeah? Okay. All right, so let's do... Ooh, I'm going to give you a challenge one. Okay. Here's the deal, right? This one already has a clue inside. It's this one at the bottom. Here's the challenge. Actually, I'm not going to give that to you. I want you to find the measures of all the angles on the inside of this guy to my right here. All right, fine, Obide. That is only going to tell you how much the total is in this 5-sided figure. Or how many sided? It's 1, 2, 3, 4, 5. That's not an octagon. They say that's an octagon. Oh, well, actually, that's not going to help you. Yeah, 1A has nothing to do with this guy because that's not an octagon. That's a pentagon. So, oh dear, you're on your own on this one. I want you to find the measures of all these angles. H, M, L, K, and J. That's going to be your challenge for the next 10 minutes. Don't say that. You're going to kill yourself, okay? But I guarantee you're going to need a lot more room. So if you want more room, work on a whiteboard on a whiteboard. On a whiteboard, my friend.
Wait, you just want to know what all of them are equal?
All of them. H, J. They're not all going to be equal to the same thing. They're going to be all equal to different numbers.
Each one of them are equal.
Each one of them. Yes, Georgia. Georgia. I'll help you guys out.
On the packet, this is about 4 points, but on this one, it says it's worth 5 points.
That'd be worth 5 points. Yeah. Go with the answer sheet. Sorry about that. We're missing a few people. Yeah. David. Obide's not here. Zane's not here.
Hello.
I'm kidding, Obide. I recommend you. You're a real person. Maria, rest your soul.
I can't relax. It's bugging me so much. Nope. This isn't.
What I do is I just draw 5 sides, or I just draw a side, connect it to another side, connect it to another side, and hopefully by the end, yep, and then just draw the last one. Who knows? It's 5-sided, it's good enough. That's what I do. Nice. That one works too. Okay, so the question is, what are we going to do with all these angles? 142. So luckily, Jay, you already found out it's just 142. I just got to figure out the rest though. Yes. Any other question? Okay. Are you okay so far?
Yeah.
Okay.
Oh,
Yeah, it's an angle.
God. Just kidding.
The whole thing.
I just wondering where you got the 30 from. Oh, and you're right. It's 14.
Mhm.
That says 14. Yeah. So that's okay. So it's 14 and 14. Let's see. You got the 6 x and 4. Yeah, you got the 6 and 4.
Let's try it.
Yeah. It's just that one. Yeah. Let's see. So you got X. So let's check this out. You got. Oh, so you did 3x is equal to 540, right? So the trick is though. Here, can you see this? You might want to see what each one is equal to. K is equal to 2x, right?
Okay,
L is equal to 3x plus
the
14.
3x plus,
M is equal to 3x plus 14.
the 3x plus 14 didn't
Then
equal
H is
540
equal
either.
to.
The entire
Thing.
Yeah.
How about all the
Yeah.
H's?
I think
Inside. You found out.
I mean, I don't want to be wrong, so
I don't know. It's very good.
That's true. What do they all have to equal? All these, they all have to equal.
Here, I'll show you.
And then you do, or like that L and M
I don't know
are
where to
3x
go.
plus 13. Right? So that's why it wouldn't make sense to say that. 'cause
Wait,
what you're
right
saying
here?
is angle L
Yeah,
Okay.
is
I'm
equal
right
to 5.
there.
That's not true.
Okay.
You know that all equal to 4. So we're putting all of that now.
All of them.
And then solve for it.
Four.
Oh, no, try not.
Yeah, four.
You're finished. All right. Thank you very much, Georgia.
What did it say?
You can just return your outside calculator.
3x plus 3.
Oh,
So,
this one at 28 from 14.
okay. What's up? Don't worry about that yet. Okay. So first off, how many degrees can fit into this thing? Oh, 5 different angles, right? But how many degrees? Okay, so before looking at that, let's use the formula. N minus 2 times n. Okay. How many sides are there on this guy? So 5 minus 2 is what? 3 times 180 is. Yeah, it is 5. So that is going to equal all the angles. Angle H
Sorry.
plus angle J plus angle K
Yeah.
plus angle L and plus angle M. Right? What is angle H equal to? What is angle H equal to? How about J? Okay, how about K? How about L?
3x plus 14.
Okay, and how about M? So now, why
Sorry.
divide the terms? If you add all the x's together,
So,
yeah. 3 x's plus 3 more x's is 6. Plus 2 more. 10x. Then 142, 14, 14. Right? Now what do we do?
so right.
Not divide. What you want to do is you want to get rid of everything that's close to x. If it's x is separated by another plus sign or minus sign, to subtract the minus sign.
What now? Sorry.
So what is 140 minus 170? Okay. Sorry, I was thinking.
So that'd be a 4.
Wait, let me have a
This-
look.
Okay.
Instead of 4, that would be
You gotta explain to me.
I just got
Okay, I will. Sorry, I'm trying to juggle.
Oh, wait, maybe not because my grandmother picked me up.
to get rid of that number from X.
Yeah, I think my grandma picked me up.
I'll show you charity.
Yeah.
Okay, yeah, that's right. So this is what all the angles equal if you're curious.
Alright. And the thing is, no one is equal to just one.
So
So
basically,
it's something. So
say-
H is going to be
You want to explain it to me?
H and K.
I got it.
What is it?
one. It feels equal to just X, but it's not
You
equal
have
to
to
just X. It's equal to how many X's? No, just this angle here, K. What is it? Okay, so what does that mean we're going to do with X? No, look at that. Just look at this. There's 2 X's here. There's 2 X's here, and then we have a singular X there. All you have to do is solve for this. So, uh-huh. And then H is equal to the same thing, so it's H going to be equal to.
Okay, that makes sense.
Right? How about L?
That'd be 3X, so that'd be
No, I was saying.
3X plus 37
Six.
times 37.
that'd be
There's not correct English for geometry.
so that'd be 100.
So 111. No, it'll be 100 and, yeah. Because that's 9 times plus 2 is 9 plus 2 is 11.
114.
Ouch.
Yeah. And then how about M? That's it. There you are. Yes, it does. Alright, where are we right now? Oh, it's okay. Yeah, and you're just solving for X, right? Okay, got it. It's alright, yeah. Whatever number or whatever letter makes sense. Yeah. Just subtract 7 plus that'd be 10x is equal to 370.
Wait, no, it's just not.
10x. Don't worry about the 10x there. Pretty good. There you go. Then you divide both sides by 10. Yeah. X is equal to 37. Good.
I should just be like, this is all wrong.
Well, that's right.
Oh, I thought you were gonna say it's wrong.
Yeah,
It's gonna be so
it's
sad. I was gonna swear if I could do that. Well, this one.
Let's do 3 times x, which is 37. Plus 14. Yeah, you're right. Yeah, that's it. Very good. Oh, Luke, it's 125, I believe. Sorry. 111 plus 14. That's 125. 135. Okay, so you got x equals 37. You're good. Very good. Very good job. Nice, Sophia. I see that your window is going up there. Okay, good job. Good job. All right, I'm gonna give you about like another half a minute. Oh wait, it's we get out 1:45, correct?
Yeah.
Oh right, because you guys are finished now for the day. My apologies. We'll continue next week, or actually, I'll post up a video. I already have a video posted up for the previous class that went over 8.1, 8.2. So please review that. I might just start on 8.3 next week. So I'm just gonna post up the video for 8.2 and 8.1. So I believe I have a video on this already for 8.1, 8.2. Okay, so go home and then make sure you watch that sometime over the weekend, and then starting next week we'll start on 8.3. Good job, you guys did absolutely fantastico. Okay, all right, you guys have a splendid day.